All right, what I'm going to do to start out with today is go over the skeletons and specification for assignment 3, part B. So the objective of this part of the assignment is to learn how to synchronize the behavior of those async tasks that you use to implement assignment 3A using a reader's writer lock called Java StampedLock, which we'll be talking about shortly. And you'll also be implementing it using a semaphore that's implemented using a Java built-in monitor object, which we'll be covering later. You can see more information about StampedLock at the videos linked here, and you can find out about Java built-in monitor objects at a number of videos. Naturally, we'll cover all this stuff in class as well. In this assignment, you'll basically replace the previous implementation of the PalantiriManager that you implemented for assignment 2B and 3A, which you used in assignment 3A, to use the new StampedLock and Semaphore implemented with a built-in monitor object. As always, there's lots of stuff here. You just have to focus on a handful of directories. You'll be implementing the StampedLock simple semaphore package, which is part of the PalantiriManager portion of the assignment. That contains a bunch of skeletons you'll have to fill in. We'll talk about that in a second. And as always, there's a bunch of unit tests, both JUnit tests and an Android instrumentation test. And make sure that you run those, please, because you'll find many, many bugs with your program if you do so. You'll also, of course, have to take the async task solution from assignment 3A and integrate it in with your solution for assignment 3B. Make sure, of course, that you do all this after I give you comments so you can address those and improve them. Please make sure that you include the assignment 3A components when you submit assignment 3B, so that way I can go back and check that you addressed my comments. So here are the main things you'll have to do. Everything's in the StampedLock simple semaphore folder, which is not the StampedLock simple semaphore folder. It's the StampedLock simple semaphore folder. And there's a class there called StampedLock simple semaphore manager.java. That's the implementation of the PalantiriManager class, superclass, and you'll have to fill in the various to-do methods. We'll take a look at that in a second. And then there's also the simple semaphore.java class, which you have to implement using a built-in Java monitor object, which is a slight variation on the reentrant lock and condition object version you did for assignment 2B. It's really not that hard to do, but I just want you to get a little bit of practice using monitor objects as well. As always, things are correct if you can run the instrumentation tests or just run the application from the emulator and it doesn't blow up and it comes back with a green title bar versus a red title bar. And of course also, as I said before, please make sure you run the unit tests. There's some additional work for the graduate students using Java 8 features. Those are clearly marked in the skeletons, as we'll see in a second. You can grab the stuff from my GitHub account. Everything should hopefully be linked and ready to go there, including all the tests. So take a look. If you have any problems, let me know, and I'll fix them. The purpose of this assignment, just to wrap up the overview, is to give you experience using StampedLock. We'll talk more about that in a second. We'll also be covering StampedLock here shortly. It's a very, very interesting synchronization mechanism that has a whole bunch of features for upgrading and downgrading locks from write locks to read locks and vice versa. And you'll also get a little bit of experience with built-in monitor objects. OK, so that's basically the overview of the specification. Let's now go take a look at the skeleton itself. So if you were to download the code from my website, you would find it's got a bunch of folders, as always. Make sure you copy your beings implementation in here using the async task implementation from before. And we're going to take a look at the Palantiri portion. Now, there's two parts here. The first part is to implement the simple semaphore class using a built-in Java monitor object. This should actually be very simple. It shouldn't take you very much time at all because, in some sense, built-in monitor objects are easier to do for this kind of simple assignment than the reentrant lock and condition object because they're just built in, as the name implies. So you'll have to define a count on the number of permits. That's going to be pretty much the same as before. Make sure that you do it in such a way where it'll be properly pushed through the caches, so it won't be cached in multiple thread or core caches. You have to implement the constructor. There's a couple of acquire methods you'll have to implement. One that acquires things in a way that can be interrupted, and another that's going to acquire the semaphore in a manner that can't be interrupted, but which will note that it was interrupted, just doesn't return until it finishes. You'll have to implement the release method. Make sure that you do the little optimization that we've talked about. You can do the same kind of trick here that we do with the random lock condition object implementation. And then there's also a method to return the current number of permits, which should be very simple because you should be defining a permit field that doesn't cache any data and can be read or written to atomically. So that gives you a big hint. So that's the simple semaphore. Should be a piece of cake. The StampedLock simple semaphore manager is more interesting because it'll be using the StampedLock, as the name implies. You'll have a simple semaphore, which you will have implemented using the monitor object. And there's a Palantiri map, and then there's a StampedLock synchronizer that's used to protect the state of the Palantiri map. And you'll have to basically implement the logic here. So the first method you'll have to implement is the build model implementation, which will basically initialize the Palantiri and initialize the semaphore and initialize the StampedLock. So those are all things that should be pretty straightforward based on what you've done before. Now we get into something that's way more interesting. And this is the acquire method. So this is the method that's going to be acquiring an available Palantir from the Palantiri map. And as the specification says here, you basically have to figure out a way to do this in an interruptible manner. So it could be interrupted. And you'll be needing to iterate through the map. Now, it's important to use an iterator for this, and I'll explain why you'll need to do that in a second. And so basically what you're trying to do at a high level is you're trying to search through the map, and you're trying to find the first non-busy Palantir, and then mark it as busy, and then return it. So that's the kind of the high-level view of what you're trying to do there. The way it works under the hood is actually fairly subtle, and we'll talk about some of the mechanisms of how to do this shortly. But what you're going to do is you're going to use a stamped lock. And a stamped lock is this really cool mechanism that allows you to do both multiple readers who can simultaneously be reading the state of this object in parallel or concurrently. But whenever there's a writer that wants to make a change, then the way the mechanism works is it ensures there's only one writer at a time. So that's why it's a readers writer lock. So readers is plural, writers is singular. And what you'll need to do is you'll need to start out by acquiring the stamped lock in read mode, and then so you can basically read through the map of Palantiri looking for one that's available. And that doesn't require any write mode because multiple things can be reading, trying to find the first available Palantir. And so when you find an available Palantir, what you need to do then is you need to upgrade to a write lock. And so there's a mechanism we'll talk about for doing that with stamped lock. So once you've found an available Palantir through a read-only mode, then you want to upgrade it to a write mode. And if you succeed in doing this, you'll use what's called a conditional try. You'll try to upgrade the lock from read mode to write mode. If you're successful, in other words, if there's no contention at that point, then you're in write mode, you update the state, and then you'll return the Palantir that was available, which is no longer available, of course, because you just marked as busy, and you'll release the stamped lock on the way out using a try finally block. However, if you're unable to do the upgrade from a read lock to a write lock, in that case, you're going to have to basically start over from the beginning of the iteration sequence and start looking from the map from the beginning again. And the reason for that has to do with the concurrent mode in which this is taking place with multiple threads. So it turns out that this code is rather tricky. So I recommend that a good way to learn what to do is to take a look at the StampedLock documentation and look carefully at the upgrade example that they give in the documentation. And that shows you the gist of what to do. So that's what you're going to have to do there. So this code is non-trivial. It's very cool, but it takes a little bit of thinking to get it right. Mercifully, release is a lot easier because all you have to do for release is simply acquire the stamp lock in write mode to begin with, and then that will block, if necessary, getting exclusive access to the lock. And once you've got exclusive access to the lock, then you can go ahead and put the Palantir back into the Palantiri map. Okay, so those are basically the things you'll have to do. The bulk of the complexity in this implementation is the acquire method doing the conditional write lock upgrade semantics. So that's what you need to focus on. Okay.